right, so on this first one, the first thing you got to do in order to make life easier on you is look at your graph. And I know it's kind of blurry up on the big screen, but look on your document. What is on my y-axis? Position. What is on my x-axis? Time. So back in the day when you guys were first learning how to do slope, you knew that slope was my rise over my run. That was my rise over my run, or my change in y over my change in x. Do you guys remember that a long time ago? Okay. For us, we said on my y-axis, that's a change in my position over time. Well, change in position over time is what? Yeah, that's your velocity. Okay, so our slope here is going to be representative of velocity. Okay, so number one, this is a position time graph. So what type of graph is this? This is position time. If this was distance time, what would my slope be? Speed. Good. If it was velocity time, what would my slope be? Change of velocity over time would be, yes, acceleration. Acceleration. All right, so number two, we already got this one. What does our slope represent? This is our velocity. All right, so take a look at A. So this is where being able to read your graph is really important. At time 0, what is my position? 0. At 10 seconds, what's my position now? 60. So did I move towards start or away from start? Away. So if I have a positive velocity, that means I'm moving away from start. Okay, so I moved away from start. Could I actually calculate the velocity? Of course. How much did I run or rise? I went up 60 meters and I ran how much? 10 seconds. So I could get that my actual velocity there at 3 would be careful, give me a direction and units. Good. Or you could just say a +6 meters per second, either or, okay? Or if you want to say the 6 meters per second away from start, you can say it that way as well. All right, at B, what does he do for 5 seconds? Where's his initial position? Come here at this point. Where is he? 60. And then here, where is he? 60. So if my slope is 0, slope of a horizontal line is 0, that means velocity equals 0 meters per second because the person is standing still. So you could say standing still, or you could say that they are stopped, but they are not moving. Okay? All right. I know this one wasn't asked, but along C, take a look at C. Where am I heading? It's a negative velocity, but it's negative because I'm going where? Yeah. So I'm going back to start, or in the negative direction. Okay. All right, take a look at D. So from here to here. This one's a little bit trickier. I was at start right here, right? And then now I'm away from start, but I moved in what direction? The positive or negative direction? Negative, because I have a negative slope. So for D, I have a negative velocity, and it's negative only because I'm moving in the negative direction. So I am moving away from start. But it's in the negative direction. Okay. And then what about E? I now have a positive velocity because I'm going back to start, but I'm going in what direction? Positive or negative? Positive. Good. So for E, I'm going back to start. But I'm going back to start in the positive direction. Okay. All right, 6 would like me to calculate my total distance, okay? In the first 10 seconds, how far did I walk? I started at 0 and I walked to 60. At B, I was at 60 and I'm still at 60, so how far did I walk? 0. At C, I was at 60 and then I walked to 0. How much ground did I cover? Don't give me a sign. I just want to know how much ground did I cover. 60 meters. And then I was here and I was at 0, the starting point, and then I walked to D, which would be look at your y-axis, 40. And then I was at this position, negative 40, and I walked back to start. 40, another 40. So if I add that up, what do you get? 200 what? Meters. 200 meters. Good. All right, calculate the total displacement. That means I don't care what happens in the middle. I want my x initial and I want my x final. So my initial point is 0. My final point's 0. What's my displacement? Yeah, 0 meters. Good. All right, calculate average speed. To get speed, I take distance divided by time. So my distance was 200 meters. How long did that take? Read your graph. 55 seconds. Do you see how I'm including my units there? Okay, so when I write it, I want to make sure I'm including my units so that I know specifically what my units are at the end. All right, so if we take 200 divided by 55, I get 3.64. But, ooh, if we keep this to the correct number of sig figs, there's only one sig fig there. So if I wanted to keep this to the correct sig figs, it would just be 4 meters per second. Or if we went 3 sig figs, 3.64. Okay. For velocity, it's my displacement over time. So that would be 0 meters divided by 55 seconds, which gives me 0 meters per second. Okay. Do I have to include a direction for something that's a 0? No, I don't necessarily have to. Okay. All right, what do you guys think on the first one? Were you guys able to know whether you're going away or towards start or if you were stopped from the gizmo? Did the gizmo help? The gizmo, I know you guys don't love gizmos, but that one is really good because you actually see a person moving. So you can correlate their motion with their speed, the time, and then the graph, the subsequent graphs that we get. So definitely use that as a resource if you need it. All right, can I have you guys give this one a try? So we just talked about position and time. So I'm going to set up my x-axis and y-axis. So I'm going to put at the very, very top on my y, this is my position. And then this is my time. All right, can I have you give this one a try? So graph a person driving away from their house, covering a distance of 20 meters in 5 seconds. They miss a turn and run into a tree and come to an abrupt stop for 2 seconds. Oh, I want to be you driving. Scared, the driver runs back home crying at 1 meter per second for 10 seconds. Okay, so I want you guys to go ahead and give this a try. And then go ahead and let's see if yours matches with mine. Our scales may not be the same, but the key is that the shape of the graph is the same. All right, so here is my graph. So do you guys all have your initial position? So check yours. Do you have your initial starting position here at 0? And then did he make it 20 meters away before? And let's see, 20 meters in 5 seconds? Is that your first point? Good. And then for 2 seconds, do you have a horizontal line? All right, now answer me this. I made a mistake on this. If they run back home, what's their total distance they're gonna have to cover? 20, right? 20 meters. So since it says they run home crying at a speed of 1 meter per second for 10 seconds. So I knew I was at 7 seconds here. So I added 10 seconds and that gave me this point here. Okay. The goal was to kind of indicate that my slope is a little bit different, right? Because I'd be going a little bit slower. Well, in all reality, if I'm going 1 meter per second for 10 seconds, how far did I run? 10 meters. Did I make it back home? So how many of you guys actually stopped your graph there at 10? So it would have been your actual graph. Let me go ahead and erase that one. If you had followed it like it was how it was written, it would have actually looked like that black line. But I wouldn't have actually made it home, right? I would have had to at least have run at 2 meters per second to get there in 10 seconds or made my time 20 seconds. Either or. Okay. Is your shape at least correct? Good. Good, good, good. All right, so that is position time or distance time. Again, make sure you're looking at it. Make sure you're careful with, am I moving towards, away from start? If I'm accelerating, is it a straight line or a curved line? Curved line, right? Now, did I have changes in speed in this example? Yeah, I did, right? So if I was to take this one and convert it to a velocity time graph. All right, so on the first one, I covered 20 meters in 5 seconds. What's the velocity? Yeah, positive 4 meters per second. And I'm going at 4 meters per second for 5 seconds. So I would put my dot up here, 4 meters per second. And I have 4 meters per second for 5 seconds straight, right? And then from 5 to 7 seconds, what is my velocity? 0. I'll put a line here. And then it said that I went crying back home 1 meter per second. So I'm in the opposite direction. So that would have been a -1. So I would come down here to -1 meters per second. And that was for 10 seconds. So there's 17 seconds. Okay. Now, you can draw yours just like this. This is perfect. Or you can put dotted lines in between, because what's happening here is that it's an instantaneous change, okay? So instantly they came to stop. Now, in all reality, is that possible? No. But if you hit a tree, do you think that's pretty instantaneous? They're gonna stop your car pretty fast? Yeah, okay? Obviously, in real world, it would take some time, but that's kind of why we use those dotted lines to connect it, okay? Remember, a horizontal line on a velocity time graph means that my acceleration equals 0, and I'm moving here at a positive 4 meters per second. Here I'm at a 0 meters per second, and here I was at -1 meters per second for my velocity. Okay? So that's how it would work if I would want to transition from this graph to my next graph. Okay? I would just calculate my slopes on my position time and then add those on to my velocity time graph. All right, take a look at this one. Help me out. Looking at my graph. What type of graph is this? It's a velocity time graph. So then what does my slope represent here? Acceleration. So my initial velocity is how fast? 6 meters per second, right? Positive 6. Don't forget your direction. Then at 2 seconds, I was going 6, but at 4 seconds, I'm now going how fast? 12. So I have a positive acceleration, right? And it's a positive acceleration because I'm speeding up. So I went from 6 to 12. So V final minus V initial divided by my time was 2 seconds. So what does that give me? Acceleration equals positive 3 units meters per second squared. Good. All right, so what's happening from 6 to 9 seconds then? Or I'm sorry, 4 to 6, we skipped that one. Right here, horizontal line. Does that mean I'm stopped? Nope, it just means acceleration equals 0. I'm moving at a constant speed. Boom. All right, how about from 6 to 9? I was going 12 meters per second, and now I'm going 0 meters per second. Slope positive or negative? Negative. So I have a negative acceleration, and it's a negative acceleration because, is it that I'm speeding up in the negative direction, or is it because I'm slowing down? Slowing down. So remember, you've got to be careful. You got to ask yourself, well, is it negative because I'm slowing down? Or is it negative because I'm speeding up in the negative direction? All right, so this one's actually slowing down because my final velocity is 0. Okay. All right, 7 says calculate your acceleration from 0 to 2 seconds. Well, it's a horizontal line, so A equals 0 meters per second squared. We are not accelerating at this first part. From 2 to 4, we already calculated that. That was a positive 3 meters per second squared. And then at time 9, what happened here? Yeah, they came to a stop. Came to a stop. Okay. All right, so do you guys see how it's all about reading the graph? And kind of asking yourself, well, based upon what's on my y-axis, what's my velocity or what's my position? Did my velocity change? Did my position change? Those are kind of the questions you're going to have to start coaching yourself through. You don't necessarily have to memorize that a horizontal line means the acceleration 0 on a velocity time graph. But if you can go to your velocity time graph and say, well, hey, this part of the line, I'm going 6 meters per second, and then here I'm going 6 meters per second. I guess I didn't speed up. Okay, that's all you got to be able to do. Okay, you do not necessarily have to memorize it, but you do got to be able to read it and interpret it. Okay, and explain the motion of the individuals.